So we're going to finish off, but showing you a few things. 6.2 is really counting techniques. Let's review what we've already looked at. First of all, counting words, so to speak, words, uses the exclamation point, which stands for factorial. Make sure you divide by any duplicates to get rid of those duplicates. Can't count them twice if you can't tell the difference. There's also something what I call license plates. But you can use this for a whole lot of things. Suppose that you had 4 ways of doing something, or perhaps 5 ways. Those are those letters. There's 5 ways of grabbing the first letter in lions. 4 ways after you grab the first one of grabbing the second letter. 3 ways, 2 ways, and 1 way. Sort of factorial again. But there can be different situations here. Perhaps for license plates, if you had 2 letters, you could have 26 ways because there's 26 letters. If you required that there'd be no problem for having 2 letters that are the same, this one could also be 26. So a letter and a letter. But maybe this is a number and another number. 10, because we can do 0 to 9 for a digit. And suppose they could not be the same, then you'd have to do some counting down. So 26 times 26 times 10 times 9. That's that fundamental rule of counting that you get. Now we're going to add to that something called NPR. These are permutations. And NCR, combinations. Order is important for permutations. Order is not important for combinations. So, things in this situation, suppose you had all your books, and suppose none of your books were the same. Then you could tell which book was which. And if you wanted to know of your books, how you could arrange these 5 books. Perhaps you have 10 books. There's 5 more over here. And you have 10 books, but you're only going to put 5 at a time on a shelf. If the order is important, then you'd use permutations. And the n would be the total. But you're going to just put 5 on the shelf at a time. You're going to store the other ones away. So 10p5. Permutations, the formula, is n factorial over n minus r factorial. Combinations are n factorial over n minus r factorial, but then we got to get rid of all those because you don't care if it's the math book and then the English book, or the English book and the math book. Those different orders are not important. So you get rid of those by getting rid of those combinations that are the 5 doing this factorial in denominator. So the difference between a permutation and a combination, permutation will be a lot more because you're dividing by less. Combination will be less because you're dividing by more. So for this situation, this is 10 factorial over 10 minus 5 factorial, or 10 factorial over 5 factorial. Remember, you cannot cancel and make that 2 factorial. It didn't work. You have to do 10 times 9 times 8 times 7 times 6 times 5 factorial over 5 factorial. This is still a big number. Is there an easy way to do that? You might have noticed when we had the calculator in here last time, but yes, there is an easy way to do that. So we're going to clear this out. If you go into Math and prob, you'll see number 2 and number 3 is NPR and NCR. Now, if you pick number 2 right away, if you've got the new operating system, you'll be able to put this value in. There's the 10, use your arrow keys, and there's the 5. And 10 choose 5 is 30,240. Or it's 10 times 9 times 8 times 7 times 6. 3240. So either way you want to do it. If the order you didn't matter, if you had math, science, math, then you'd use NCR. Math prob number 3. You'd put in the 10 and the 5. And this is 252. Much different, because you're dividing by that 5 factorial, that extra 5 factorial. I'd like to finish off this page at least by saying NPR and NCR are one way of writing that. P with N comma R and C with N comma R is another form of writing the same thing. So if you see that, it's this NPR, NCR, same thing, same formulas. Okay. Suppose we have 8 boys on the student council and 9 girls, and we need a committee of 4. How many ways are there to choose all boys? Well, when you've got these 2 groups together, you have to really think about both of them. Because we don't care about the order, there's nothing here about a president, vice president, or whatever, chairman of committee or whatever. So we don't care about the order, we're going to use NCR. So all boys means there are 8 boys, choose 4, and 9 girls, choose 0. Whenever you see and, almost always in mathematics, it'll mean multiplication. And really it goes back to that idea of a tree. Now, if we do this together, we have NCR, so we go math, prob, NCR, let's see, 8 and 4, times, go back and get that again, math, NCR, 9 and 0. And what do you get? 70. Okay, but that doesn't really tell you what's going on in between or between these two. What is just 8 choose 4, or 8 combined with 4? Let's go back and do that one. Math prob 8, 4. Well, you get 70 for that. Well, then what the heck is 9 choose 0? So 9 choose none, you get 1. So that's what we're doing. This was really just, there are 70 ways to choose a committee of 4 boys from the 8 boys. If you don't choose any girls, there's only one way to do that. You don't choose any girls. So if you ever come up with that, or if you ever come up with 9 choose 9, see, math prob, oops, do that again, math prob number 3, and you do 9 choose 9, you'll also get 1. This really comes from Pascal's triangle, and we'll look at that in a second. But you can use your calculator to do all these, and this combining of stuff really helps you figure things out. How about all girls? Well, that'd be 9 choose 4. We could say and 8 choose 0, but we know that's just 1. So what does 9 choose 4? Well, let's bring this back. We can always change these. 9 choose 4. 126. This was 70. Suppose we want 2 boys, 2 girls. Well, that's 9. See, I'm sorry. 8 is the boys. 8 choose 2. And, which means multiply. 9 choose 2. So what is 9 choose 2? That's 36. What is 8 choose 2? Well, we can go all the way back and get this, call it 8 instead of 9. And that's 28. And what is 28 times 36? 1008. Of course, you could have put in math prob the 8 choose 2 times, you don't have to put the times even, math prob and 9 choose 2, you get the same answer. So if you combine these things by saying, okay, you can do 1 boy and 3 girls, that would be 8 choose 1 and 9 choose 3, 3 boys and 1 girl. You can do all the combinations, the ways of choosing. If you don't care, these are committees. I call these like committee problems. As a last problem, let's do a license plate problem. Suppose this license plate always consists of 3 letters, then 3 digits. But they're not going to allow the I, O, and the Z, because unlike my Z, which has a line through the middle, the Z looks like a 2, an O looks like a 0, and an I looks like a 1. So, and also you cannot repeat the letters. So first of all, we don't have 26 letters anymore. We only have 23. If they can't repeat, then you can have 23 for the first, but you've used 1, so 22 for the second, and 21 for the third. And then you need 3 digits. According to the rules, they can repeat. So you could have 0, 0, 0, or 1, 1, 1, stuff like that. So there are 10 ways, 0 through 9, to repeat those and get the digits. So how many ways total? This is just multiplying things out. 23 times 22 times 21 times 10 times 10 times 10. So how many license plates can you make? It's 10626,000. So 10,626,000 license plates. Now, will that be enough license plates for a state? Maybe not. You can have a whole bunch of cars that you need a license for. And I don't know if you include trailers and other stuff. Anyway, that's section 1, section 2, and section 3. Do read your text. It does a good job of explaining these. And work on the problems at the end of the chapter that would include these types of questions. We'll see you later. Bye.